Telescopes by Chelsea Tipton
and Lindsay Dennis.
The history of telescopes, the first telescope. In 1608, Hans Lippershey, a German-Dutch lensmaker, was the first one to ever think of a telescope, although it was unclear on whether he was the first one to build one. He did, however, have a design made out for the first telescope.
Hans invented the telescope for seeing things far away as they were nearby. He applied to the States General of Netherlands on October 2nd, 1608, for a patent for his instrument, but he was denied the request since it was the same claim for the invention that was already purposed by other spectacle makers.
Other inventors of telescopes. In 1609, Italian physicist Galileo Galilei decides to build his very own telescope after hearing about the new device. Galileo took the basics of Lippershey's design, but improved it in many ways.
Using his new telescope, Galileo discovered many different exciting features in our solar system, like the 4 largest moons of Jupiter, Io, Europa, Callisto, and Ganymede. Other important telescope inventor was Sir Isaac Newton. Newton was responsible for the development of the reflecting telescope. How does a telescope work? Telescopes capture images by bending and reflecting light through a series of lenses or mirrors.
Primary lenses are round and bend and aim light towards the secondary image. Secondary lenses focus clearly on the object producing the images that astronomers study.
What are the different types of telescopes? Refracting telescopes use converging lenses to collect light. Reflecting telescopes are telescopes in which a mirror is used to collect and focus light.
There are 3 different kinds of reflecting telescopes. These include Cassegrain, Newtonian, and Nasmyth. Cassegrain telescopes reflect light that passes from a secondary mirror through a hole in a primary mirror. Newtonian telescopes are small angled mirrors that deflect light from a main mirror, enlarging the image seen. A Nasmyth telescope is a sideways reflecting light that passes through a main mirror.
Properties of telescopes. Light collecting area. Light collecting area telescopes that have a larger collecting area can gather a larger amount of light in a shorter amount of time. A telescope's diameter tells us the light collecting area of the telescope itself.
The largest telescopes that are currently in use have a diameter of about 10 meters. These telescopes are known as the twin 10-meter telescopes of the W.M. Keck Observatory located in Hawaii. These telescopes are owned and operated by the California Association for Research in Astronomy. Remember, bigger is better. Angular resolution is another property of telescopes. Angular resolution. Telescopes that are larger have the ability of taking images with farther more detail. This emphasizes that at a greater distance, 2 stars would likely look like one light rather than 2, but one can still see the one light. As an object gets closer in view, the angular resolution becomes larger.
It is in this way that a larger telescope has more ability to take images in more detail because it can get closer to the object. Ultimate limit to resolution comes from interference of light waves within a telescope. Larger telescopes are more capable of higher resolutions because there is less interference from light waves.
What do astronomers do with telescopes? Imaging, taking photographs of the sky and solar system. Astronomical detectors can generally only record one color of light at a time. Therefore, in order to make an image with more than one color, several images are combined.
Astronomical detectors can also record forms of light our own eyes cannot see. False color may be used to represent different energies of non-visible light. Astronomers also work with spectroscopy and timing. Spectroscopy is the breaking of light into spectra, the study of the interaction between matter and electromagnetic radiation. The spectrograph separates the different wavelengths of light before they hit the detector.
By performing the dissection and analysis of an object's light, astronomers can predict the physical properties that object may have. Examples include temperature, mass, luminosity, and composition. Timing. A light curve represents a series of brightness measurements made over a period of time. What is interferometry? Using multiple small telescopes to reach the same resolution that you would get with a larger telescope. Smaller images are combined to assemble a much larger picture.
This method is mainly used for defining angular resolution. One drawback is that it doesn't collect as many photons as a regular telescope would.